Hey everyone, welcome to a exciting first series in the Critical Thread Best Practices. I'm Brian Spellman and this is Andrew Sparrow.
Good morning, everyone. Brian, welcome back. It's been a long time. Been missing you, man. Missing you. So we are really excited to bring some real depth. We call it inch wide, mile deep. Everyone is talking about the digital thread these days, but we're talking about the critical thread, the fastest way, the critical path from a great idea to putting a product in your customer's hands. We're focused on the discrete manufacturing industries, and we'll be identifying the very best practices across the entirety of the product lifecycle that we deliver solutions for.
Yeah, today we're going to be diving in and talking about quality management in the high-tech industry. We're going to be talking with Ron Watkins, who is a wealth of knowledge. He is an industry process consultant with Dassault Systems for over a decade. Ron has extensive experience in high-tech electronics, both in commercial and aerospace and defense, particularly dealing with printed circuit boards, box builds, manufacturing tests, warehouse material. He has over 20 years of experience in high-tech, and this is going to be a fantastic deep dive.
You bet. Everyone, please, welcome to the show again, but remember to ask questions. So as we go through, please, there's a little button on the side there that allows you to put your questions in, no matter what they may be. Get in there. We're going to keep pulling back to you to keep reminding you. But in the meantime, without further ado, let's get ready, set, let's go. Ron, how are you, sir?
Doing great, Andrew. Thanks for having me on today. Good to see you, Brian.
Good to see you. We're excited about it. As you can tell by this low-key intro we gave for you, we're excited about having you here.
You bet.
I didn't want to give the true years of experience. I didn't want to date myself too much, but you can judge by the hairstyle like Brian.
We're all in there with you, Ron. We're all in there. Good. So, Ron, we provide digital engineering and smart manufacturing solutions in the consumer electronics, technology suppliers, big area, including kind of PCBs, box build, battery manufacturers. And we know there are some real challenges in achieving the essential quality of product at the end of the day.
So while you're here, can you just help explain to us the importance of quality management in the high-tech manufacturing industry?
Yeah, that's a good place to start, actually. Why is today's topic even so important? First and foremost, if you think about it, behind safety, quality is the most important thing. You have to satisfy what your customer wants, or you're not going to be able to keep that customer. You're not going to have a sustainable business. And we all know it's a lot easier to keep an existing customer than to get a new customer and bring them online and have them loyal to you. So, the key in quality is ensuring customer quality, making sure the customer's happy. And that's really where quality management comes in. In addition to the customer, you probably don't want to get regulatory fines. There's things you need to monitor in the process, rules and regulations that you don't want to violate, because you could get some very, very expensive fines that have been in the news lately. And then the other thing that all of us should be concerned about is sustainability. So the higher quality the process, inherently, you're going to have less waste, less scrap, and it's going to be a more sustainable system. So that really should be key to all of us.
Get you. So how does an integrated approach to quality management impact the overall organizational culture, drive continuous improvement within a high-tech manufacturing company?
Culture is very, very important. You read any of the books on quality and it talks all about cultures. Culture is not something you can teach. It's not something you can have a HR regulation book on. Culture really has to be part of the company from the top down, but adopted and followed by everyone in the organization. So a good quality culture is baked into the process itself. So people don't even realize that they're doing quality type activities, but they are. It's just the way they do business. It's the way they think. the way they act. When I'm on a facility and I'm walking around in meetings, whether it be with executives or doing a shop tour, you can always sort of tell how well that culture is around quality when people are just in every conversation, just talking different things that really instill a sense of these people take pride in what they do. They really want to produce good quality product, and they know what they need to do to produce the quality. So when it's supported from the top down with the right metrics and incentives, as well as enhanced by everyone in the organization, it's a great situation for quality.
Yep. So talking to kind of top down, let's talk systems. When we were getting ready for the show, we kind of looked out and found a whole bunch of questions that are out there that hopefully as we go through, here we go, we're able to address. If not, we can circle back to. But what I'd like to do now is really dig into a good quality management system, answer these questions. What do you think are the key components of an effective QMS in manufacturing?
So for me, it's, that slide's very busy, and obviously not everyone can read every single one of those, but it's what we saw there was a business process, an integrated business process that, has suppliers, engineering, production. There is a quality department, there's inspection, but that is not quality. The quality management system needs to encompass the entire business process. So, and quality management system, it isn't software. That's where we get into an enterprise quality management software system, but you need to have a system and defined business process in place. So if you look at, research that's been done by LNS and others, 78% of companies interviewed say that they have a disconnected quality environment. And, that's what's really the root of a lot of their quality issues. So it's these siloed applications, and not just applications, but siloed organizations that look at quality maybe as, oh, that's in the next station, they'll take care of it. But, this is what we need to avoid, are these silos, and have that single platform, that single voice of the customer throughout the end-to-end process that's being enforced.
So let's just pick up on that, Ron, just quickly. So one of the questions we've got in here is in the high-tech industry, how can we collaborate and ensure conformity in terms of parts or tooling received from suppliers? I get it, it's the single platform. What else could be done?
Yeah, so supplier collaboration is a key part because they're part of the ecosystem that's going to ensure the quality. And a lot of times when I get requirements or customers talk to me, they want a system for audits, or we need source inspection, or they need to supply us with this data. But think of it not so much transactional, but as you mentioned, more collaborative, and think of your suppliers as your partners, because their success will enable your success. So give them what they need to be successful, and vice versa. So have a collaborative platform where they can come in, have discussions. You can share model data up front. Requirements are clearly understood. If you look at the importance of quality management over a time frame, most of the quality is set up front, or a lot of the quality is determined up front. So the sooner you can involve your suppliers in this, do your FMEAs and define for manufacturing and quality, which I think we'll talk about a little bit later, and provide this information up front, but involve your suppliers with it. Then once you do start producing, so you shift to the reality side, that's where you need to have things like error proofing. And that's all the way back to your suppliers, not just in your four walls. And then you go out, if you get non-conformances, you deal with them. Unfortunately, sometimes escapes happen. Then you've got to do some containment within your four walls, make sure nothing's gone out to customers. If it has, then that's where you may have to do recall or something, or at least audit what's out in the field. So the longer you wait in that timeline, the more costly your quality is going to be. And I think that's a fundamental principle that probably a lot of the people on the call understand, but we really have to start back with the suppliers, the original customer requirements, and making sure everyone's on the same page.
Yep. Got it. Yeah. I mean, the sequencing, everybody involved. I mean, the root cause of so many organizations these days is everyone operating in a bubble. Yeah. probably a lack of empathy for what each other does, etc.
It's frustrating for some of the people on the shop, and that's why I love to hear the voice of the customer. And for me, when I'm touring a shop, the customer is the operator, or it's the inspectors, the warehouse people.
Yep.
That's who we need to, and they'll tell you what their challenges is. And I think I gave you guys a slide of the different, the challenges that you have in your environment. And it's, they get mixed messages from people. So they've got to go into this system to get this information in this system. And it's sort of like driving a car with all these GPSs. You're so, frustrated looking at all these things, and you have to decide which one is more important than the other. And you're so focused on these different systems that you really lose track of the goal, which is driving, or in production, it's producing good product and, getting it delivered on time. So, this is very frustrating. You're right, Andrew. And, people, I haven't met really anyone in a production facility that says, I want to produce bad product. Everyone wants to produce good product, and they just want to be given the tools and empowered to make the decisions to produce that good product. So, if you look at, really what the best practice is today, it would be a very sleek, heads up type display with one clear vision for the operator to see, how to proceed forward. It learns as it proceeds down the path. It gives you options if things arise like traffic. And enabled to do this, you really need to have that, one common data model, user interface, and end-to-end process that pulls together all of this information and presents it to your users in a very streamlined manner.
You're getting into great stuff. I mean, this is really game changing. A lot of the stuff that's coming in now that is so imperative. Maybe we can come back to that. All this said and done, aren't there some standards out there that people should be following to at least get that platform in place, procedural, if nothing else?
Yeah, no, that's a good point. We all need to follow a standard. One of the most common standards is ISO 9001. I really like that standard from the standpoint is it lays out some very specific quality tenets that you need to follow. And any company, really, regardless of the industry, is either following this standard or another derivative of the standard tailored for their industry. But the first and foremost, like we've talked about, is quality focus. So, we mentioned the requirements have to be baked into the design. The design then has to have quality plans and things to ensure that design. So it's got to be, quality focused, from the customer standpoint. And then you need to have leadership. So the leadership is really defining the standardized processes that are efficient, talking quality from the top down, and incentivizing, people to really care about quality and want to have a clear state of quality path going forward. And talking about the people, you really need to engage them in the process, empower them with the data that they need to make good decisions so they can produce their quality product. And then you need to have that approach or your business process. And as we talked about, that needs to cover end to end, not just a quality or a production. It really needs to cover all facets of the organization. And then, because we very rarely get everything right 100% of the time, first time, we need to have a basis for continuous improvement. So having that baked into the process, having the ability to make changes, improve the process, roll those out has to be key in your quality management and making decisions based on data. Hopefully we'll get in later about artificial intelligence and prescriptive and advanced analytics, but that's coming more and more into play. And I see this happening now. This isn't some, futuristic Star Wars thing. This is going on now. And then relationship management. It's really involving all of your stakeholders, from your suppliers to, the customer and everyone in between, and allowing them to, collaborate and ensure good quality and quality plans.
It sounds like what the key takeaway from all of this, or one of the key takeaways, is that quality isn't an afterthought. It's something that you're making throughout the entire organization, the entire process, from, everybody who's part of the company has to be part of this whole quality effort. And all of this we've talked about so far is really a overall, I think, quality advice for any organization. Want to dive in particularly to the high-tech sector. In the high-tech sector, what types of quality planning have you seen that work the best?
So in quality for high tech, and we'll just take a step back and talk about the industry. It's very fast paced, lots of innovation, lots of products being new introduced. Ramp up is important. So again, with that velocity and speed of products, your quality system has to be able to adapt and keep up with that pace. So again, it's going to start with your quality requirements. We talked about, designing the quality up front. We do a lot of simulation in the high-tech space, not only simulation of the products to make sure it's meeting the technical parameters that the custom and the environment require, but also of the process, the equipment. You look at some of these semiconductor fab or packaging, these pieces of equipment are worth, $500 million. These are huge pieces of equipment, very, very specialized, very precise. So, that process quality is really important. So there's a lot of simulation that's done up front there. So we do as much up front as possible, but then we do need to translate those into executable quality plans, and identify, what the specifications are, sort of the what to measure, take this measurement or this reading, and then have sampling procedures, which is, the procedures would say, how to measure it and how frequent to measure it. Is it sampling? Is it 100% inspection, X-ray type thing? And then all of that needs to be evaluated against what, again, going back to the customer, making sure that the customer and any other regulatory requirements are being met throughout the process, and then keep track of that and control that process. So that's what's really key. But the velocity and just how fast things happen in high tech is sort of what makes it exciting.
So it's taking all of this and just trying to find a way to fit it all in a rapidly changing environment, which sounds like an exciting or difficult challenge.
It can be, and I've worked in both very, very large scale, high volume, but then also smaller scale. When I worked at Motorola, I was in a small space group, so we were building Iridium satellites, which back in the day was a high volume for satellites. But yeah, you have to be adaptable to that environment.
So how do you approach developing and implementing a quality management program in a manufacturing facility?
Well, so, a lot of what I do in my current role at Dassault Systems is, talk to companies exactly about that. And, the first thing we do is we listen. So what is it that they're trying to solve? Ideally, we would have the greenfield environment and we can play king for a day and we can design our ideal quality management system or talk to them about their vision of it and make that a reality. But you really have to look at the current landscape. They may have things that are working very, very well in high performance business processes, and maybe they just need a few things to complement those solutions. But in doing so, you do need to, as we've mentioned, look at the end-to-end process. Even if one system's not doing it all, you need to look at how data, how people flow and interact with that process. So, from quality to production to maintenance. And, that's really where, we have a philosophy of business process management and a process building tool that allows you to string together those business processes end to end and take inputs from external systems if needed, but then also pass information to those systems as well. Also, standardization of that quality process needs to be done. So you need to have some sort of center of excellence and governance model to evaluate processes, take in the feedback from the shop floor, and then evaluate, what is the best practice and standard process across different lines, organizations, and even plants. So you need to have a tool of how do you codify these and then enforce them, and then how do you deploy them to the plant. So we tend to use a thing called Global Process Manager that allows you to quickly deploy, monitor how well those processes are performing, and then if need be, make additional changes until it's refined. So just really continuous improvement and agility is key.
Ron, where does we all meet every day? Somebody wants OEE measurement. Where's that fitting in today in the bigger picture? I mean, I don't know. The C-suite's kind of great, but what am I going to do about it? I don't know. Where do you think that fits in today?
Yeah, I think over the years we've had a lot of conferences and books and probably webinars all focused on OEE, and it's really become sort of a catch-all term. But and we, like probably most software companies, we have a standard out of the box OEE calculations, but then no customer defines OEE. Maybe they're more interested in the quality, the uptime perspective of it. So yeah, we do use that term OEE, but we really look at the individual components of it more, and that's the granularity that management might want to look at a nice dashboard number and say, oh, I'm green, I'm good. But at the operational level, which is where I tend to feel more comfortable, we need to give more information behind those numbers. So it's okay to put a big number, but definitely your operators are going to drill down very, very quick and get into more advanced analytics for problem solving. But it's sort of like the red light, green light type thing.
Got it. Good. Okay.
So
good question though.
When you are, I guess, diving into the red light, green light sort of thing you're talking about, you're going to have certain methods and tools to monitor, to measure productivity, to measure the product quality in a manufacturing environment. So what do you use?
Yeah, no, the product data as well as the process data is key. And whether that data comes in manually, so someone takes a measurement and keys it into the system, or if there's a high-speed machine and it's kicking out data and it's then being analyzed, that the key is the data has to be good. It has to be standardized in a format that's in context so that it's usable. If you're just capturing data for capturing data, sure, it's good for retention purposes, and a lot of requirements, customer requirements, have certain retention of data, but you're really missing the boat on that data and what you can do with it. So I think we have a slide sort of to explain sort of our approach of how we look at this data acquisition in high tech. And, I title it Learning and Improving Quality from the Bottom to the Top, because a lot of that information is coming from the equipment, either individual equipment passing information, or also in the case of, the manufacturing operations management, which includes all your production, your quality, warehouse. So it's bigger than traditional MES. It has the order data that also can provide context down to the shop floor. So it's really a cyclical type data feed. And so batch information, order information is being fed down, maybe programs, but then the data that's being acquired from the line is coming up through the IoT layer. We might get in some of that detail a little bit later, but for Sandpoint, there's really two types of data. There's your operational data and your detailed analytics data. So the beauty of this approach is that within the manufacturing operation management, you can combine operational data with some analytical data. So you may need to require to get certain profiles, what profile was used, scrap rates, things like that you want to display in dashboards for your operators. But then there's this advanced continuous analytics that's always running, acquiring high-speed data, putting it in this data lake, and standardized analytic reports can be run on that data, and it's providing you insights into your operations. It's smart so that it knows that if it needs to alert, either through color coding, operator alerts, maintenance alerts, so it learns as it goes along, gets more data from other lines, other plants, and it assimilates this. So it has a learning component in it. And then it can do actual prescriptive and predictive type. You could say, hey, I think we need to send a maintenance alert, get maintenance over here. We've got a solder profile or something that's trending out. Or prescriptive, hey, you have this problem with this component being improperly placed. Here's some data. And we've seen that head number 4 of the pick and place machine is lower pressure than the other heads. Hey, this is also why this component is being placed by this head. So it sort of steps through a process to then tell the operator, you may want to check that head. You may want to shut down the machine. So it can prescribe steps to take to fix the problem. So that's where we're heading. And I know, Andrew, you're real excited.
Yeah, I got to come in. You're putting a little peek into a window, which I think is just the future, and it's fascinating. You know, every day we get in our vehicle and we ask Siri, whatever it is, or maybe it's just me, but how do I get here? And then you set out on your journey, and then there's something that happens on the freeway, and it reroutes you. That is not happening in manufacturing, and that needs to happen in manufacturing.
Yeah.
It's like the ways of manufacturing, if you will. How close are we to that? I mean, you're just touching here. I mean, the elements are coming together, but when do you see that coming in?
I think it's here, right? I think it's happening, and it's been happening to some degree, maybe lower tech version, right? We've all know about FRACA systems and systems that'll sort of step the troubleshooting process through, but those are very, I'll say, linear. Do this and then go down the tree to try to figure out. So, but the next generation of that is looking at multi-dimensional data across several lines, several plants, analyzing it very, very quickly, and able to learn and spot patterns in the data. So if these 5 or 6 variables are this, then that sometimes results at this high percentage of a defect. So it's using that advanced analytics and the learning capability. And we're doing some pretty exciting things right now with that, and some partners that we're working with that we'll be talking more about that later. But it's an exciting field, Andrew, like you.
Yeah.
This is where this is one of the things I've been waiting for a long time, and now we've got this technology, so it's pretty
cool.
Just to be clear here, you're saying that right now we're bringing all the stuff in the news about AI is now coming into manufacturing. So when you're saying learning and figuring out these patterns, you are talking about machine learning and AI integrations.
Correct. Using those type of algorithms, the algorithms. Probably you or particularly myself, I don't quite understand the details of how all they work, but it's pretty incredible what they can predict and some of the accuracy. But the key is having this data, having it in the right context, the right format, so that these systems can utilize it.
Got it.
And then I did want to just close out that slide. If you could put back up that slide. We talked earlier about the importance of the design and the model. So we're big on the virtual twin experience for the product, the process simulation, and the resources involved in doing all those. So this also provides a feedback loop. So based on the analytics data, it can spot trends and raise alerts or notifications and route them to design engineering, for instance, for review. And so then the design engineers can go in and further dive into this data and drill down and see if they can do something more with this data and then improve their design. So it's the virtual world helping us improve the reality world, and then the reality giving a feedback loop to improve our virtual model. That's sort of the unicorn of what we're really working towards. We never get to 100% one-to-one, but the more information you have up there, the closer and closer you can get, and it can become pretty predictive, your virtual twin, of what's actually going to happen. So that's some exciting stuff that we're working on. Thanks.
What do you? I think you probably swept up a lot of them, but what are there any other kind of key challenges that organizations face when they're implementing a comprehensive data-driven quality monitoring and control system, especially in terms of integrating the machine data, the accuracy of the data in the whole analytics process?
Yeah, it is. It can be challenging, and it has been a challenge for us as well as many vendors, because if you look at machine integration that we talked about, I showed it as a nice line, right? But the reality is, and we'll focus on high tech, fabrication, all that, whole different robots, different scenario. But all of the modern equipment is great. It's trying to follow the open standards that are being developed through IPC and other organizations. But as we all know, unless it's a greenfield, you're not going to have all brand new equipment. A lot of our facilities have older equipment, maybe don't follow the standards, or some just they don't abide by the standards exactly how they should. So it does pose a challenge in there. So the key in the way that we address this is, by having this machine connection level that can handle the volume of data that you get from the high-tech industry, and then contextualize it and put it in a format that's usable. But, without this, it'd be nice if you just connected with one standard to everything. But that's really not reality. So you have to have something with some out-of-the-box connectors to get you started quick. The ability to change those connectors to adapt to similar equipment. So starting over, and then also the tools to build connectors very quickly off higher level, I'll say building blocks, so that you can connect to these different machines and expand and create new tech connectors and then add them to your library. So your library expands over time. And this is the approach that we've always taken. But we are, when you look at specific industries, you typically will have to, look towards maybe partnering, because there's companies that do this very, very well. And so, leveraging some of their connectors, some of their analytics tools, and, that can give you a jump start in that process versus you trying to tackle all of these integrations, implementation by implementation. Although you will still do that to some extent. You're always going to have that weird or specialized tester that only communicates this way, and you have to communicate to it. But that's really, that's one of the big challenges, is getting good data in the right format, in the right context, that it can then be utilized both in the manufacturing and operation management system, along with the operational data, but also in the advanced analytics.
Okay.
So
thank you.
With all of that, you kind of, I think, have talked about, how we can ensure good quality standards, regulations throughout this whole manufacturing process. What are some more details overall of how you actually make that happen as far as those insurances?
Okay, so now we're shifting into more the quality and manufacturing execution process. So one of the things that work really well are creating these guardrails. And if you've ever been at like a bowling alley and you take your kids there, and there's these rails that you can put in the gutters, it helps guide the ball down the path into the center. And that's really what a robust quality management system and manufacturing operations management system can do. It can guide the operators. We call it, guided or directed manufacturing. And then throughout the process, put some error proofing in, Poka-yoke in other stages throughout the process to prevent errors in the first place from happening. And then if there are errors, have quality gates to catch those before it proceeds in the value chain to maybe a next tire assembly where it's getting enclosed. And if you remember the chart we showed before over the timeline, the longer in the process you wait to catch that defect, the more expensive and more timely it is going to be. So, another key one is knowledge sharing. So, when you look at knowledge sharing, how do you learn, from that knowledge on the shop floor and apply it? The more senior people, that's a big challenge right now, is we're having to revamp the workforce and get a new generation of workers in, because of the workforce. A lot of that knowledge is walking out the door as we move on in time. So, we need to really have the tools in place to capture that knowledge. And then, lastly, I just want to add, genealogy is a key thing. Some people implicitly put that with quality. It's usually a responsibility of the quality organization, so I include it in there. But being able to, have that enhanced genealogy, that traceability, that as-built record of both product and the process of what happened, and then that comes in handy down the line if you ever do need to do containment type activities where you have an escape and you need to put your bookends and find what products do I need to check or audit. So those are some key things to ensure that.
Yeah, I'm getting the impression from listening to you that you have done, you're not just talking about this from a theoretical level, but this is stuff you've actually experienced, hands-on. So Can you maybe give an example of a quality issue that you encountered in a previous manufacturing role and how you went about resolving that?
Yeah, no, it's a good point. It's as good as our universities are, they don't teach you all of this stuff in there. So some of it I've had to learn from the School of Hard Knocks. So yeah, probably I was a quality manager for a program, a space program, and I was put in charge of the Mimic assembly facility, and so that's where we're taking the dies, we're putting them on the substrate, we're putting the wire bonding, enclosing them, lots of testing. Very, it's in a clean room environment, and we had this particular quad flat pack that we were using as well, and it was very, very fine pitch, and so we were really worried about the process and getting it positioned properly. And we would get down the line and we would go to test it, and it kept failing. So initially, we were raising defects on it. We thought it was something process related. We'd even done design of experiments on the process to optimize it on the placement of it. But then, we escalated it. We went through a root cause analysis and said, I think our process is doing it right. There's something inherent with this device. So we opened up a SCAR, or a supplier corrective action report, and sent it out to the supplier. And we worked with them. We didn't just send them a nasty gram and say, you fix this. We worked with them, collaborated. We had several collaborations, where we went through the design, and, long story short, it turned out to be sort of a lack of clarity in the requirements that were left open for loose interpretation. Okay. So they technically had delivered to what we had sent them, but not what we meant, which happens. So that just goes back to the importance of clearly defining requirements that can be followed. So, we worked with them to put together an action plan. We were still in prototype phase, so we still had some time for production. We had to do a workaround, so we had a white wire type repair on it so that we could get through prototyping and the next higher assembly testing. And we had a few golden units that we could use for that. But, that's an example of, initially you might think it's something wrong with the process or that, and it went all the way back to the requirements. So that's why I keep hammering on this. It's an end-to-end process. Any link in the chain can be the cause of the problem.
Yeah. Well, along those lines, then, how do you go about approaching or identifying what the root causes are for quality problems in manufacturing?
Yeah. So, that's, typically when you have, in this example I just gave, there was some initial or preliminary root cause, which was done by our production. So any good, non-conformance thing, you're going to define what the issue is. You typically will list something. Sometimes it's very obvious, like I dropped the component, or I opened the package and it didn't look right. So maybe that was the root cause. But at this point, it's usually preliminary. And I think, in the example we gave, we were really focused on the process when we needed to expand that a little bit more. So the root cause analysis has to be data driven, first and foremost. So you have to go back to your data, and that just goes back to the importance of that level of analytical data that we can look at and the advanced analytics involved in that. And then it also, your root cause analysis has to be people driven. Typically the answer lies within your team, extended team. Someone knows the answer. It's just using the formal, CAPA process, the different tools, the 8 disciplines, the 5 whys, the Ishikawa fishbones, those type of tools, using those. And we have a tool for collaborating called 3D Lean Board. And the 3D Lean Board is something that pulls together all the stakeholders, and it can be used for your shift meetings, where you go through your quality and go through your defect trackings, and you look for maybe design changes. But it really engages the whole team in the process and allows them to try to uncover and improve the process themselves. So this is something, and it taps into, so it's pulling data from other systems. So if you have critical data from the analytics, that can be displayed in your team board. So everyone's involved in this, and it allows you to use and document the problems. And instead of, a lot of us have used these in factories, the whiteboard, right?
Oh yeah.
Stood around the whiteboard. I think we had Post-it notes back then. So we put Post-it notes, we scribble stuff.
Oh, Kanban.
Yeah. Well, and you learned and you declared victory. Maybe you all went out for drinks after work to celebrate. But then, like 2 months later, on another program, the similar thing happens. And so what this does is it captures electronically all of this data, and it actually can route these are actions that are being created with electronic Post-it notes that are actually routed to individuals or organizations to be done. So it involves people. It has accountability. It has traceability of what was done to solve the problem, and it really drives towards that root cause and getting everyone involved.
Which is a theme I keep hearing from you, is get everybody involved. Your whole organization, everybody's important in figuring out how to get the best quality. And I'm sure that over the years, with what you've done, you've come up with some strategies to help prevent quality defects and from even occurring in the first place. So share some of your knowledge there with us.
Yeah. So, over the years, in my working experience, I was more on the manufacturing quality material side. But in recent years, I've really got involved more with the engineering side. And so some of the stuff that we do a lot of is around DFX. So design for quality, manufacturability, sustainability, repair, all those, different design for excellence type criteria. And we do that through our virtual twin. So we can, create the virtual twin of the product. We can model the factory, all of the equipment. We can do process failure mode and effect analysis, either on the process or the product. So when you look at a FMEA, it allows you to go down and try to identify upfront all of the potential problems that you're going to have, and then what are the possible causes of those, and then solutions of those. And those can be used. In addition, you can use these then to create, reports that can be followed, but also you can create your corrective action plans. This is a good tool to go back for, but your quality plans come out of this. So, if you're suspecting that this error or this defect may occur, put in place a quality plan that manufacturing and quality can execute, and take these measurements and then make sure they're within this parameter. It may not be a customer requirement, but it may be an indicator that something is wrong. So including those PFMEAs is an important. Also doing simulation and assembly evaluations. So being able to, we've got an example of where, just the basic assembly sequence of putting this battery in this speaker, there were wires that ran by it too close. So by simulating it, you can see the proximity of these wires, and from a manufacturing engineer, they can see this and identify it up front as, hey, this is a potential area for assembly making a mistake or creating a defect. This wire could be pinched. And then your design engineers can evaluate that, and maybe they put a shield in it, or maybe the manufacturing engineers put that wire in after or something. So, being able to virtually go through the build helps you identify some of the potential issues as well. So that's something that we use too.
Great.
The other thing, go ahead.
No, I was going to say, what about things such as AR, VR, mixed reality? How's that coming?
Yeah, so that's good. I was focused more on the upfront, but during the execution, providing your operators with more robust, easy to understand, work instructions to guide them through the operation is key. And you always say a picture's worth 1,000 words, a video's worth, I guess, 1,000,000. And then when you get into augmented reality or virtual reality, I guess that's worth 1 trillion words or something. I don't know. But we've done a lot with AR, VR, and that's another exciting area that I'm working with a lot, particularly in high tech. When you think about augmented reality, you think about it in a big, structure that you need to highlight things to rivet in that. And that is, our augmented reality solutions are very big in automotive, industrial, but also in high tech. If you think from the standpoint of the training aspect, a lot of that equipment is very, very difficult to use. So I think I've got a video or something of of augmented reality, and the idea behind this, and the main difference, and people get this confused all the time, so I'll explain this, but the augmented reality is you're dealing with reality. So you actually have a physical product or a machine, piece of equipment in front of you, and then we can overlay the augmented reality over it. So if you think about a quality inspection step where you need to check 5 different areas, that can be overlaid, and you can span in it. So this is another area, and I'll come back to the augmented reality.
Did I pull up the wrong video?
Yeah, this is a good one too, but this is something we do for virtual quality defect tracking. So instead of just textually saying component IC6 has a bent lead or it's skewed part, you can physically pull up the board in 3D. We support 2D as well, and you can document the problem right on the board, the severity of the problem. You can take a picture of the defect, attach it to the defect. So it's more robust defect documentation. So thanks for pulling that one up.
And just then on AR, VR. So I'm just, maybe it's a bit of a pitch, but I mean, we're hearing a lot about Dioda, this new, fairly recent acquisition by DS, which is all around that AR, VR mixed space. We saw some incredible stuff with, dare I say, Airbus. Obviously, it's AMD.
Yes.
How are you seeing that impact in the high tech sector? Then I think you've touched on it, but am I in the right area here?
Yeah, no, it's and if you think about it, it's not your typical thing that would come to mind, because you've got automatic inspectors inspecting the circuit boards. But one area recently that you'll see this little video that sort of shows how the AR system. So if you look at modular board build, or say you're building a speaker or a controller, this happens to be a prototype of a controller for a EV, and you need to connect these things. You want to make sure they're done right. Well, you can overlay on the actual product itself to make sure it's right for the operator. And then in the quality inspection step, you can verify with some templates. So some of these, if you think about in the semiconductor space, large pieces of equipment, very, very complex pieces of equipment. One of them is just guiding them through the setup and the maintenance. So if you think about facilities maintenance needs to maintain this equipment, the maintenance procedures can utilize the 3D model of the equipment, which we have. We deal with a lot of semiconductor equipment companies, and then it can utilize, and we can take in multi-CAD. So it doesn't have to be our CAD format. It can be other versions of CAD. And then we create this augmented reality experience, and you author these just like you would author any other work instruction or quality inspection aid. And it's accessed by the operator from this. So it's, again, creating the 3D, utilizing it in the manufacturing or quality space, and to ensure the proper quality. So that's, some benefits, that you mentioned. Dioda, that is the company we acquired a while ago and is now part of Delmia. So it's part of the Delmia brand. That's where the authoring will be done. That's obviously where the execution will be done in Apriso. But if you think about like reducing your defects, they've seen improvements of like 90% reduction just from interpretation errors. If you've got a picture or something or text, because it does poke yoke it. It highlights specific things to draw your attention. It's going to reduce, they've seen significant reduction in rework and scrap, and then just the operator skill level, accelerating their development and upskilling to a level. So it's like having a mentor right there with you that you can tap into if you need it. So it's pretty exciting stuff.
So you're saying that augmented reality is for more than just catching little creatures and these little red and white balls.
Exactly. Yeah, that sometimes is fun too.
From Poke-Yoke to Pokemon. Great.
Exactly. Oh, I
Thank you,
love
bro.
that. You got to coin that, Andrew. And then the other side, virtual reality, which we've been doing for a while too, is taking that and you can put in the goggles and you can be completely immersed in a virtual reality world, which is also really good for training. We had a complex assembly. You're basically building it before you build it, and I've participated in those several times, and they're a lot of fun. And after a while, you think, oh, I could build this. Put me in, coach.
You bet. You bet. Fantastic. Ron, we have got so many more questions, but I think we're kind of getting right to the end now of our time slot. A big thanks to you. I know we need to go back to that other slide, but that's going to have to be, I think, another time. Really helpful, great advice, great best practices, plenty of do's and don'ts in there. So exactly what we were hoping for. High-tech QM, challenging world, but plenty of solutions out there. Big thanks, Ron.
Thank you. I appreciate you all hosting me here, and I love your podcast, your show. I try to catch as many of them as I can live, but they're also a good, the recorded ones too are always good to go back and check out. You can learn a lot from a lot of different industries and a lot of different disciplines. So thank you for having me.
Yeah, we really appreciate your time for coming on here. This has been very informative. I think this is the kind of thing that even being part of this, I still want to rewatch just to see what I missed for, what was said. So a lot of good information here.
Thanks again. Thanks, cool. Ron.
Thank you.
So everyone, thank you. Next month, September, we return. We are going automotive this time around. We're talking internal combustion engine and ACES, autonomous connected electric subscription vehicles. And we're talking quality management. So that critical thread walks QM in automotive. Looking forward to that one with Mike Bradford from Dassault.
Yeah, so we'll see you all next month. And thanks for joining us.
Thanks, everyone. Have a great month ahead.